be monitoring tonight's launch with Flight Director Garrett Henn at the helm. Mission Control is go for launch, meaning the space station is ready to receive the spacecraft, and we're not tracking any issues that would prevent a docking. From here on out, mission controllers will observe the launch and monitor the Dragon vehicle during all milestones of its flight. The astronauts on board are likely to be asleep at the time of launch. There are 7 people living aboard the International Space Station now: NASA astronauts Jasmine Mogbelli and Laurel O'Hara, Andreas Mogensen from Denmark, Satoshi Furukawa from Japan, and Roscosmos cosmonauts Konstantin Borisov, Oleg Kononenko, and Nikolai Chub. When the Cargo Dragon arrives on November 11th, it will dock autonomously, but O'Hara and Mogbelli will be on deck to monitor its arrival. The crew will first unpack the more time-sensitive science experiments and cargo, and then, as the week goes on, continue to unpack their delivery. They'll be receiving some pizza kits, olives, an assortment of cheeses, and some holiday treats like pumpkin spice cappuccino, cranberry sauce, and chocolate. So I'm sure they're looking forward to it. In the meantime, here in Mission Control, everything is still a go, and we're looking forward to following along with the Cargo Dragon during its journey to the International Space Station. So for now, let's go back to Kennedy. Jasmine?
Thank you so much for those updates, Chelsea and team. We are now at T-minus 19 minutes and counting from liftoff of the 29th Commercial Resupply Services mission from NASA and SpaceX. This mission will carry 6,505 pounds of cargo, including supplies to support the crew on board, spacewalk equipment, vehicle hardware, computer resources, and of course, science investigations. So let's take a closer look at what's on board. Launching on this mission is part of NASA's first two-way laser communications relay system known as Illuma-T. After attaching to the outside of the space station, this laser communications terminal will send and receive data through NASA's LCRD satellite on orbit. Using invisible infrared light, laser communications can transmit data up to 100 times faster than traditional radio frequency systems. Illuma-T brings this capability to the International Space Station, enabling more data to be transmitted and received. And of course, more data means more discoveries. Also on this mission is the atmospheric waves experiment known as AW. This heliophysics experiment will capture the first global observations of atmospheric gravity waves that form near the surface and impact Earth's upper atmosphere. Increasing our understanding of these waves could teach us more about Earth's atmosphere, climate, and near-Earth space weather. AW is also part of what NASA is calling the Heliophysics Big Year, a global celebration of solar science and the sun's influence on Earth and the entire solar system. Our work in low Earth orbit is, of course, paving the way to deep space as we shoot for the moon and beyond. Around this time last year, Artemis 1 lifted off, and for Artemis 2, NASA plans to send a crew of 4 astronauts around the moon farther than humanity has ever gone before. To learn how about we're getting there, let's check out our Artemis Moon Minute. Preparations for NASA's Artemis 2 mission are underway at Kennedy Space Center. Engineers inside the Neil Armstrong Operations and Checkout Building connected the 2 major components of the Artemis 2 Orion spacecraft, the crew and service modules. Once in space, these important pieces of hardware will fly the Artemis 2 crew around the moon and back. The 10 solid rocket booster motor segments for the Artemis 2 Space Launch System rocket arrived by rail at Kennedy, traveling from Utah across 8 states in specialized transporters. Kennedy teams also are conducting several water deluge tests at Launch Pad 39B, releasing approximately 400,000 gallons of water onto the mobile launcher's deck, flame hole, and the pad's flame deflector. By helping to deflect overpressurization and suppress the sound produced at liftoff, the water deluge system is critical for protecting the crew, rocket, spacecraft, and